Hello friends, welcome back to Dr. Jackie's Academy. In today's lecture, I will discuss the components of the autonomic nervous system, and the very important component of the autonomic nervous system is the sympathetic nervous system. So in this lecture, I will discuss about the synthesis and metabolism of the adrenergic drugs. So let's start. So mainly in this video I will focus on the catecholamines. I will discuss what we mean by catecholamines, then how the important neurotransmitters like noradrenaline, adrenaline, they are synthesized, what we mean by this adrenergic neurotransmission, how it takes place, and how the actions are terminated. Okay, all these are things we will discuss in today's video. So first of all, what we mean by this term catecholamines. So if we take this nucleus, this is a benzene and these are the two hydroxyl groups, and if two hydroxyl groups are adjacent to one another in the benzene, this is called as the catechol nucleus. And if we combine amine also, so that means catechol plus amine, so we are having the catecholamines. So what are catecholamines in our body? Endogenous. One is noradrenaline, which is called as NE, it is also called as norepinephrine. We are having adrenaline, which is also called as epinephrine. We are having the dopamine. Okay, so these are the important endogenous catecholamines in our body. So now, how these catecholamines are synthesized? Chemical synthesis. So the process starts with this amino acid, phenyl, this benzene ring, alanine. There is a amino group, there is a carboxyl group, that is why it is a amino acid. So the first step is the hydroxylation. So you can see at this position, hydroxylase will attach the hydroxyl group. So, and in this process, phenylalanine is changed into the tyrosine. And in another step, again hydroxylase, the enzyme, will add another hydroxyl group at this position, so that we are having this catechol, and this tyrosine is converted into the dopa. This is again a important step. Now there is a decarboxylation, that means this carboxyl group now will be removed. So if this carboxyl group is removed, okay, so now we are not having, this was the amino acid, but this is amine, this is dopamine. So dopa is converted into dopamine when you remove the carboxyl group. So one carbon atom is also removed. You can see this one, full carbon atom is removed. So this is the synthesis till dopamine. Now we will discuss further. So this is the dopamine I told, this is the catechol, and this is the amine. Now there is another enzyme that will act. Specifically we have written beta hydroxylase. Beta mean this is the alpha position, this is the beta position. Okay. So now at this beta position, this hydroxyl group is attached. So now we have a noradrenaline. So noradrenaline will be converted into adrenaline when you are having this methyl group at this position. Okay, and how this methyl group is added? With the help of this N-methyl transferase. That means the enzyme which transfers methyl group at the N position. So this is adrenaline, noradrenaline, and this is the dopamine. So this is the important mechanism, you can say the steps involved in this synthesis. Coming down to the adrenergic neurotransmission. Neurotransmission means how the you can say information is passed from one nerve terminal to the another nerve terminal. Let's say this is the one nerve terminal, this is the another nerve terminal. Because the information is coming from this side to this side, we'll use a term presynaptic terminal, and this junction is called as the synapse. So this is presynaptic terminal, this is presynaptic membrane, this is the postsynaptic membrane, and on the you can see in this presynaptic terminal it is expanded like a knob, and within this one we are having a number of vesicles, and these vesicles, they have stored neurotransmitters. Because we are talking about the adrenergic neurotransmission, so neurotransmitter will be the, most of the time it is the noradrenaline. 80% of the cases it is noradrenaline. In some of the cases it is adrenaline. Okay, norepinephrine is the major neurotransmitter in the adrenergic neurotransmission. So we are having the neurotransmitters, we are having the receptors located on the postsynaptic membrane, and we use the word adrenergic receptors. So now this is the static position. So how the things will proceed? First of all, action potential will come, it is coming. As it will come, it will depolarize the whole membrane, and the changes take place so that this neurotransmitters comes from this vesicle and binds to these receptors. And when these receptors are activated, there is a transmission, we can say there is signal transaction. So this is how the adrenergic neurotransmission, how the impulse passes from one to another through the neurotransmitters. Now, another thing, once this signal has passed, now how the action will be terminated, how the neurotransmission will be stopped. Now there are three methods. Number one, I will discuss all these methods in detail. Number one, reuptake of neurotransmitters at the presynaptic terminals. Reuptake of neurotransmitter at the presynaptic terminals. Second, vesicular transport. Third, metabolism with the help of two enzymes. One is MAO and second is COMT. I will discuss both reuptake and vesicular in one slide. Now, reuptake. So this was the thing that where we stopped. Presynaptic terminals. These are the neurotransmitters. These are the receptors. Now, if the action has completed, so what will happen? Now, so I'm using this is cytoplasm, which is also called as the exoplasm. Now, there is an important role of these transporters. They are called as norepinephrine transporters. Okay, so these transporters, where these are located? These are located at this side. That is presynaptic membrane. They are located. So what is their function? Now, these neurotransmitters which are present in this synapse, they are reuptaken, they are reutilized by these transporters. So this is how they are moving inside. Okay, so this is the reuptake. Now they have entered in the exoplasm, but this is the storage site, vesicle. So that means now they will start moving inside the vesicles, and this process is called as vesicular transport. So this is how it is going inside. So two steps of termination. One is reuptake at this site. Second, transport inside the vesicles. Third thing we will discuss, metabolism of catecholamines, that is chemical modification. So now this was the, I have taken the structure of the norepinephrine, noradrenaline, where this amino group is present and there is a hydroxyl group. So metabolism can take place at two positions, either at this position, amino position, or at the hydroxyl group. So depending upon, because we are taking about two conditions, so there are two kind of the enzymes. One is called as monoamine oxidase, MAO, monoamine oxidase. So as a name indicate, monoamine, single amine oxidation, where a single amino group is present, it is oxidized. So at this position the action will take place and it will be oxidized. Second, catechol O methyl transferase, as the name indicate, at this catechol nucleus, at catechol hydroxyl group, methyl transferase, some methyl group will be transferred. Okay, so acts at the hydroxyl group as the phenyl ring, and there is a transfer of methyl group at this three position. Actually, you can say it is the third position. This is the 1, 2nd, 3rd, and 4th. This is third position, which is on which the COMT act. So now, another important thing that I want to discuss: what is the metabolite? What is the final product that is formed if the metabolism will take place? Now, let's say we are talking about adrenaline or noradrenaline. If monoamine oxidase enzyme acts, so we get some intermediate product. Then subsequently COMT act. Okay, so that what I am saying is first MAO act, then COMT act to produce a metabolite which is called as vinyl mandelic acid, which is called as VMA. Where it goes out from the body in a urine. So that means if in a urine you get lot of VMA, it means there is a lot of noradrenaline. But if the levels of VMA are reduced, that means catecholamines are reduced. But this is one thing I have told. First MAO, then COMT. But opposite can also take place. That means first COMT can act. If COMT will act, then you get metanephrine. Okay? COMT can act at noradrenaline also, you can get normetanephrine. Okay, so whenever the methyl group is attached, we use the word meta. So it is metanephrine, it is normetanephrine. But more important, what I am telling, COMT, the action is followed by MAO, but the reaction, the final product is same. Whether the MAO acts first or the COMT later, or COMT and then MAO, vinyl mandelic acid VMA is the major excretory product. So now one last thing, when MAO will act first and when COMT will act first, what are those things? Okay, so now, so let's say this is the presynaptic membrane. Okay, this is the neurotransmitter which is present in the exoplasm. Now this is acted upon by the MAO. So MAO first attacks on the catecholamine which leaks from the vesicles into the cytoplasm. So any neurotransmitter which is coming from this vesicle to the outside or which is coming from synapse into the exoplasm, axonal transport. So this is, if it is present in the exoplasm, it is acted upon by monoamine oxidase. Now, where the COMT will act? COMT acts on catecholamine which comes in the blood or in the circulation. So COMT is rich in the liver or other tissues which metabolize the catecholamines. So in the upcoming video, I will discuss the pharmacology of beta agonist, or I will discuss the sympathomimetics. Thank you.